Hey guys, today we're going to be solving some rational equations. I'm just not 100% back to full health, so while I am in the room and I am here, I just wasn't sure how much I would be able to help you, would be able to do with you. So I just thought I'd make this video lesson just to be safe. So hopefully you were able to do the drill. I'm just going to quietly work through it here. And you can check your work solving the quadratic equation. Of course, you can solve that by graphing, you can solve it by factoring, you can solve it by the quadratic formula. I'm going to solve by factoring. So x equals negative 1/2 and x equals 1. Then we need to get a common denominator to add. So, got a common denominator. Nothing else factors. So there's that. And then for our last part, we had to multiply, which means we're going to try to factor and simplify. Okay. So that should have all been review. Okay, so today our objective is going to be that we're going to use factoring to solve rational equations. I love to factor. And in order to solve using rational equations, we're going to have to factor. A rational equation is any equation that contains one or more rational expressions. So as long as it has at least one rational expression, which is a fraction that has variables, then that's a rational equation. To solve it, if we just like we would solve any equation that has fractions, we would probably want to get rid of our fractions. So that's what we're going to do here as well. But the first thing we're going to do is we're going to factor everything that we can. So we want to factor all of our algebraic expressions. We don't want to leave anything that's not factored. We want to make sure everything is factored as much as it possibly can be. Then we want to find the least common denominator, just like we were going to add or subtract. Okay? Once we found the least common denominator, we're going to multiply both sides by that least common denominator. And when I say both sides, I mean of the equation. And then we're going to solve the resulting equation. And then finally, we're going to check for extraneous solutions. And this is something that could easily happen anytime you multiply by a variable. Extraneous is a kind of fun word to say. Reminds me of asymptotes, so we don't want to have extraneous asymptotes. So let me just pause here. Well, actually, let's define extraneous roots. Extraneous solutions are any solutions to a rational equation that, when a solution is placed into the original equation, results in a 0 in the denominator. In other words, it's when a solution is an excluded value. That's an extraneous solution. It's an extra one. It's one that wouldn't have been there if we hadn't multiplied by a variable. So what I'd like to do is I'd like to just pop back over here to my paper and just kind of go over a little something here. So if you recall, back in the day, when you'd see problems that would say like x divided by 3 plus 2/3, let's not make it 2/3, plus 2/5 equals 7/4. Okay? And you'd be like, this isn't that so bad. Like, it's no big deal. Like, you'd probably add whatever. But we're just going to look at this and we're going to say, let's get a common denominator. Can't factor any further, so let's find a common denominator. Well, our common denominator of 3, 5 would be 15. And then of 5 and 4 would be 20. And then of 4 and 3 would be 12, but we need for all three of those, which would just be the product of them, which is 60. So what we're going to do is we're going to multiply every little thing by 60. So 60 times x is 60x divided by 3 is 20x. 60 times 2, which is 120, divided by 5 is 24. And 60 times 7 is 420 divided by 4, which is 105. I think I did that math right. I'm just, for whatever reason, my mind is not with me today. So I'm just going to make sure. Okay, I did the math right. And then I'm just going to solve that equation. So I subtract 24. I got 20x equals 81. And then I divide that by 20. And I find out that x is 4.05. And I can leave it just like that. But all of a sudden I didn't have any fractions and it was easy to figure out. So that's what we're going to do to solve these. We're going to follow all of those steps. So the first step is to factor. Well, there's nothing to factor here. So what's our common denominator between 2, 3, and 6? 6. So we multiply everything by 6. Now I like to write it like this. Some teachers write it like this because they're writing both sides of the equation. Others will write it so that each thing has a 6. I don't care. Because in essence we're taking 6 times x divided by 2, which gives us 3x. Then we're taking 6 times 8, which is 48, divided by 3, which gives us 48 divided by 3 is 16. Yes, yes. And then 6 times 1, which is 1. And we solve that equation. So when we solve that equation, we would subtract 16 from both sides. So 3x is negative 15. So x is negative 5. And we check, can we put negative 5 in the denominator? There's no place to put a variable in the denominator. So we're good. Same thing for number 2. What's our common denominator there? Well, for 2, 9, and 18, our common denominator is 18. So you're going to multiply every single thing by 18. 18 times t minus 4 divided by 2 is really 9 times t minus 4. 18 divided by 9 is really 2, and then times t minus 3. 18 divided by 18 is really 1 times 5. So the cool thing about this is since we had that minus in the middle, we're just going to distribute that negative 2 through. So we have 9t minus 36 minus 2t plus 6 equals 5. So 7t minus 30 equals 5. So 7t equals 30, and t equals, 7t equals 35, and so t equals 5. And again, if you try to put 5 in your denominator, it's all numbers. So that's what we're going to be doing. Okay? So, let's try a couple more, because things get a little hectic, helter-skelter. So looking at number 3 here, well, number 3 doesn't look that bad, Miss Finney. You're right, it doesn't. It doesn't look that bad because our denominator, everything has a denominator of 1 except for that 6 divided by x. So we're just going to multiply everything by x. So we have 3x minus 6 equals x squared plus 8x. And now we got ourselves a show here, because this didn't work out as easily as the first two did, but we can still solve it because we're intelligent people. So we're going to subtract our 3x and we're going to add our 6, so we've got 0 equals x squared plus 8 minus 3 is 5, and we add the 6. How do we solve that quadratic? That's right, we're going to factor it. So that factors into x plus 3 and x plus 2, because we needed factors that add up to be 5, but multiply to equal 6. So we find out that x plus 3 could be 0, which means x is negative 3. Or x plus 2 could be 0, which means x is negative 2. We go back and check. If I put negative 3 in here, it's not 0. If I put negative 2 in here, it's not 0. Both of those work. Do the same thing for number 4. So for number 4, what we're going to do is we're going to factor as much as we can. So when we factor x squared minus 25, that factors into x plus 5 and x minus 5. So what's our common denominator? Well, our common denominator is x plus 5 and x minus 5. So we're going to multiply everything by that. And this is why I think it's helpful to write it out. Because when I do that, I can see it cancels here, which gives me just 4x. Plus 2, the x minus 5's cancel, which gives me 2 times x plus 5, equals the x plus 5's cancel, which gives me x minus 5. And then you solve that equation. Now beware, because we already know that x can't be 5, and x can't be negative 5, because then our denominators would be 0. So when I solve this, 4x plus 2x plus 10 equals x minus 5. So that's 6x plus 10 equals x minus 5. So 5x plus 10 equals negative 5. So 5x equals negative 15. So x is negative 3. That's not either one of those answers. So we're good to go. Okay? Oh yeah, we got lots of time. For number 5, hey, this has a denominator of 1. So we're going to multiply everything by x minus 4. So that gives us 2x equals 8 plus x minus 4, which means 2x equals x plus 4. which means x equals 4. Well, could it be 4? If I put 4 in, I get a 0. So this actually has no solutions, because this is extraneous. Because up here we find out that x cannot equal 4, because if we put 4 in, it makes the denominator 0. So there's no solutions to that one. Likewise on number 6, there's no solutions, because if x minus 2 is our only denominator, then x can't be 2. But we're going to have x times x minus 2, because we're going to multiply everything by x minus 2. X minus 2's cancel here, so that gives us plus 14, equals 7x times x minus 2, which cancels, which gives us 7x, plus 1 times x minus 2, which is just x minus 2. And you do the math. So we've now got x squared minus 2x plus 14 equals 8x minus 2. So we're going to subtract 8x from both sides, so that's x squared minus 10x. Add 2 to both sides, so that's 16. And I'm looking for factors of 16 that add up to be negative 10. Good job. Negative 8 and negative 2. So x minus 8 could be 0, which means x would be 8. X minus 2 would be 0, which means x would be 2, but x can't be 2, because that would make it 0 in the denominator, and boom. And that's how you do the rational equations. That's how you solve the rational equations. So what I'm going to ask you to do is, on the next page, there are some practice problems. True? So what I'm going to ask you to do is find a buddy, work these practice problems, and we'll check them before we do our closure. Okay? Closure is what you're going to be turning in today, most likely. But the next thing I'd like you to do is the 8 questions there that are practice. If we run out of time, we may not turn in the closure. We may turn in something different. So be advised. Don't just jump straight to the closure. But thanks.